Hello and welcome to the second part of Lesson 2 in Unit 2A of our Grade 10 academic math class. This is right angle trigonometry and we're working through an introduction to trigonometry. We started in the first part by learning how to label triangles correctly, not just in terms of the letters, the capitals and the lowercase letters representing both angles and their corresponding sides respectively, but also where to label the hypotenuse, the opposite, and the adjacent sides from a reference angle. Then we went on to examine at least one of the primary trigonometric ratios as they pertain to similar triangles. And what we examined was the opposite side over the hypotenuse. The other two we would have examined would have been adjacent over hypotenuse and opposite over adjacent. And those three sets of comparisons correspond to the primary trigonometric ratios, which we call sine, cosine, and tangent. I made sure to point out that these are three variable equations in that it has a reference angle and two sides in each of the equations. We did a little bit of a setup, and now we're going to move on and work through a couple more examples. Now, what I'd like to take the opportunity to do right here is share something that is sort of academic wisdom passed down through the years. It's a memory aid to help you remember which ratios go with which word. So the memory aid, and you're under no obligation to use this, but it was taught to me when I was your age, and it will probably be taught to your children as well one day. So it is SOHCAHTOA. And that doesn't sound like much. SOHCAHTOA is what you do if you hit your toe, stub your toe on a desk. You SOHCAHTOA. That's a mnemonic device to help you remember it. What does it mean? It reminds you that the sine ratio, whoops, I should get a highlighter, reminds you that the sine ratio is the opposite over the hypotenuse, the cosine ratio is the adjacent side over the hypotenuse, and the tangent ratio is the opposite over the adjacent. You can just memorize it. You don't have to remember this silly little memory aid if you don't want to, but you're welcome to if you think it will help. Okay, so we have enough tools now to start to try a few things. We've been given a triangle here and worked examples. Example number 1 says, given triangle JED, find the three primary trig ratios for angle D, leave as fractions in simplest form. Okie doke. So here we have triangle JED. I've already taken the liberty of labeling the little letters as well. So we have across from side capital J, we have little j, across from side capital E, or from angle capital E, we have side little e, and across from angle D, we have side little d. This is looking good. We're after the three primary trig ratios for angle D. So they've told us that angle D is going to be our reference angle. So I'm going to color that in right now. Angle D is our angle of reference, which interestingly enough, and I didn't say this in the last video because it was getting a bit long, but you might be wondering, can we ever make the right angle the reference angle? And the answer is no. And the reason you can't do this is because the side across from our right angle is always the hypotenuse. Following that same logic, however, if this was our reference angle, the side across from it would also be opposite. And it can't be two sides at once. So we can never use 90 as our reference angle. It only serves the purpose of identifying for us the hypotenuse. The reference angle is one of the other two acute angles, meaning angles that are smaller than 90 degrees. So we have angle D. The side across from it will be the opposite. We already labeled the hypotenuse, and that leaves us with over here, this side here being the adjacent side, or the side beside the angle of reference. Now, we're going to write out the three primary trig ratios, and we are going to leave them as fractions in lowest form. However, what you're going to notice is that in this triangle, we have one side, side little e, another side, side little j. Side little d does not have an actual value yet, so it's missing. How do we find it? I will draw your attention to the fact that we are dealing with right angle triangles, and we already have something in our back pocket that helps us determine sides in right angle triangles that are missing, and it's called the Pythagorean theorem. So if we have the Pythagorean theorem, I'll just do that over here. The Pythagorean theorem says that c squared is equal to a squared over b, or a squared plus b squared, where c is the hypotenuse. So in this triangle here, we've already identified the hypotenuse as 26. And a and b represent the other two sides of the triangle. Now that's interchangeable as far as we go here. So we're going to put in 24 for j. We'll just pop that in right here, no big deal. 24. And the side that we are missing is side little d. So we're going to change that b to a d squared so that we're all lined up with the appropriate variables for this question. And now we're going to isolate d. We need to get to d all by itself. How do we do that? Well, we need to move or transpose 24 squared to the other side of the equation. We do that by subtracting 24 squared from both sides. So let's get our calculator into the action here. So we have 26 squared, and we are going to subtract 24 squared, and that is going to give us 100. So we now have 100 being equal to d squared. Now some of you might be saying, Mr. Smith, do I need more steps there? It doesn't hurt to put more steps in, but hopefully we've all reached a point where we're comfortable with what has happened there, and we can make the jump from just sort of showing the transposition, kind of like what we were going to be doing here, and then actually figuring it out into the next step is fine with me. Any fewer steps than that, it starts to look a little sketchy. So we have 100 is equal to d squared. How do we get to just a d? How do we undo the fact that it's being squared? We undo that by taking the square root of both sides, which means that we are going to have here the square root of 100, which is 10. It's going to be equal to side d. All right, we're rocking. So let's put that into our triangle over here. That's going to be 10. Now we can work on the three primary trig ratios. So let's start by writing out the sine ratio. So the sine of angle d is going to be equal to the opposite over the hypotenuse. All right, and the cosine, whoops, that's a weird C. The cosine of angle D is equal to the adjacent side over the hypotenuse. And lastly, the tangent of angle D is equal to the opposite over the adjacent. And again, I know I'm ripping through it pretty quickly. Once you work with it a little bit, it will come more quickly, I promise. So we have our opposite side. Our opposite side is 10, and our hypotenuse is 26. So we have 10 over 26. Here we have our adjacent side is 24 over 26. And our tangent is the opposite side, which is 10 over the adjacent side, which is 24. Now, this is important. It has asked us to reduce these to simplest form, which is sort of just another way of saying the lowest form for these fractions. So if we have 10 over 26, we can reduce these. The numerator and the denominator are both divisible by 2. We divide the numerator and the denominator by 2. We are going to get 5 over 13. Both of those are prime numbers. That's as low as we can go. So the sine of angle D is equal to 5/13. Let's do the same thing over here. Both numerator and denominator again are divisible by 2. And we are going to have 12 over 13. And well, 12 is not a prime number, 13 is, so that's as far as we can go here. Cosine of angle D, and now tangent. Same thing, these are divisible by 2, both of them. Divide by 2, divide by 2. And now we are going to have 5 over 12. And 5 is a prime, so that's as far as we can go. So the tangent of angle D equals 5/12. All right, we're rocking. It's feeling pretty good. These are lowest fraction forms of the three primary trig ratios for triangle JED. Let's jump on to example number 2, the final one. So given triangle HUG, or HUG, find the three primary trig ratios for angle G, rounding to 4 decimal places. Okay, so this time we're actually going to do the calculation. But let's set up our triangle here first. So we've been given our reference angle. That's angle G. There it is. From angle G, we know that the hypotenuse is going to be the one across from the 90, and there is no value there for it. That's okay. The side across from the reference angle is the opposite, and the side remaining is the adjacent side right there. And again, this would be side little u right here. This would be side little g, and this would be side little h. So once again, we're missing a side. We're missing side little u, which is our hypotenuse. We can again use the Pythagorean theorem to figure it out. Let's rip through that right now. So we have c squared equal to, c squared equal to a squared plus b squared. We don't have the hypotenuse this time, but it is the variable u that we've been using, and the other two are 15 squared plus, I don't remember, 8 squared. There we go. So we have u squared equal to, 15 squared plus 8 squared, let's figure out what that is. 15 squared plus 8 squared is going to be equal to 289, and we take the square root of that, and that gives us 17. So we're going to take the square root of both sides, and u then is equal to 17. Okie doke. So let's pop 17 on there. 17 in for the hypotenuse, and now we can start making our trig ratios again. So we have the sine of angle G is equal to, I'm not going to write it out this time, we're just going to jump right to it. So the opposite side is 8, and the hypotenuse is 17. The cosine of angle G is equal to the adjacent side, which is 15, over the hypotenuse, which is 17. And lastly, the tangent of angle G is equal to the opposite, which is 8, over the adjacent, which is 15. So it's asked us to go to 4 decimal places this time. So we can say that sine of angle G is equal to approximately, and now we're just going to literally pop it in there. So we do 8 divided by 17. It's going to give us 0.470. So that's 5/8, so we'll round that to 6. There we go. And now we're going to do the cosine. So the cosine of angle G is equal to approximately, again, we're going to type it in, 15 divided by 17 is going to equal 0.88235, so we'll round that to 4. And last but not least, the tangent of angle G is equal to approximately 8 divided by 15 gives us 0.5333. Now that's a repeating 3, but they only wanted 4 decimal places, so that's rounded appropriately. There we go. So we have worked through these last 2 examples. This again is really reinforced in the homework, so please take good copies of this note to use for your reference when you're working through the homework. If you have any questions, as always, reach out, email, directly in class, or in any other way you can get a hold of me, that would be perfect. And we're going to get through lesson number 2. I will see you in lesson number 3.